Good morning, all. Today we are going to discuss about digital logic and the microprocessor. In that sequential circuits module, we are going to discuss about shift registers in digital logic. So, what does mean by shift registers, and what are types of shift registers? First, there is a what is shift registers. So there is in combinational circuits and a sequential circuit. In sequential circuit, we are using flip flops, latches, and so shift registers are using in the sequential circuits. Flip flops can be used to flip flops can be used to store a single bit of binary data. So that is 1 or 0. And however, in order to store multiple bits of data, we need multiple flip flops. N, that is n number of flip flops are to be connected in order to store n bits of data. So that is in a single flip flop that can able to store only the binary data, that is 1 or 0. In order to in order to store the multiple bits of data, we need multiple flip flops. So there is n number of flip flops are connected in the order to store n bits of data. A register is a device that is used to store such information. So it is a group of flip flops connected in series used to store multiple bits of data. So that is called as the register. So register means there is a group of flip flops connected in series, that is operations is used to perform store multiple bits of data, and the information stored within these registers can be transferred with the help of shift registers. So what is the purpose of shift registers means that is information stored within these registers can be transferred with the help of shift registers. And the shift registers is a group of flip flops used to store multiple bits of data. The bits stored in such registers can be made to move within the registers and in out of the registers by applying clock pulses. So the data can be moved inside the flip flops and or outside. So it can be performed by applying the clock pulses. And n bit shift registers can be formed by connecting n flip flops where each flip flop stores a single bit of data. So that is n bit can be stored by using n number of flip flops are connected in the series. And next one, the registers which will shift the bits to the left are called the shift left registers, and the registers which will shift the bits to the right are called shift right registers. So there is two types of shift registers. One is shift left registers, which transfers the data, shifts the bits of the data to the left, and it shifts data to the right, means there is a shift right register. And there is different types of shift registers are there. First one, that is a serial in serial out shift register, and next one serial in parallel out shift register. So that is in out means that is we are giving the data input, serial input, and the output is getting in the serial, means that is a serial in and serial out shift register. And parallel connections, so that is represented as the parallel. In is represented as the input and out is represented as output. And next one, there is a serial in parallel out shift register, and next one parallel in serial out shift register, and next one parallel in parallel out shift register, next one bidirectional shift register and universal shift register counter. So these are all the different types of shift registers. First one, we are going to see about serial in serial out shift register, that is SISO, the shift register which allows serial input. So serial input means that is one bit after the other through a single data line. So that is known as the serial. So that is in connection, that is only one bit after the other. So that is no cross inputs are given here. That is in serial connection only. In serial connection means one next to the other, and produces serial output is known as serial in serial out shift register. Since there is only one output, the data leaves the shift register one bit at the time in serial pattern. That's the name. So the that's why it is called as the serial in serial out shift register. And the logic circuit given below shows serial in series out shift register. The circuit consists of 4 flip-flops. So 4 flip-flops are connected in series, which are connected in the serial manner. 4 flip-flops, 4 D flip-flops are connected in the serial manner. All these flip-flops are synchronous with each other, since the same clock signal is applied to each flip-flops. So this is a example and a diagram for the serial in serial out shift register. There is a 4 D flip-flop. 4 D flip-flop which is connected in serial connections. So that is one common clock pulse is given for all the D flip-flops, and the input is given as the serial input. So first input is given to the D flip-flop. The first output of the D flip-flop is given to the input of the second D flip-flop. Likewise, all the other flip-flops can be given, and the output can be performed at the last fourth D flip-flop. So that is the serial output can be obtained here. And next one, serial in serial out shift register. So this is also the same. The above circuit example for the shift register, taking the serial data input from left side of the flip-flop. The main use is to act as the delay element. And next one, that is a serial in parallel out shift register. So here the shift register which allows serial input. So serial input means one bit after the other through a single data line, and produces a parallel output. So it can produces the parallel output in different flip-flops also. The logic circuit given below, and it also consists of 4 flip-flops which are connected, and the clear signals is connected in addition to clock signal. So for first SISO, the only clock signals is applied, and by here the clear signal is also connected in addition to the clock signal to all 4 flip-flops in order to reset them. So what the purpose of we are applying clear signal means, in order to reset the data we are applying the clear signal. The output of the first flip-flop is connected to the input of the next flip-flop, and so on. All these flip-flops are synchronous with each other, since the same clock signal is applied to the each flip-flops. So this is the diagram for serial in parallel out shift registers. Here the input is given to first D flip-flop, and the first D flip-flop output is given to the next D flip-flop, and the output is taken from each flip-flop. There is 4 output we are taking from each every D flip-flop. So this is called as the parallel output. Here the clock pulses is given common, and additionally here we are giving the clear pulses. So what the purpose of clear pulses means, here that is used to reset the function. So here the common serial input is given, and the output is taken in parallel manner. So this is known as serial in parallel out. The above circuit is example for shift right register. So taking the serial data input from the left side of the flip-flop and producing a parallel output. So these are the used in communication lines, where demultiplexing of data line into several parallel lines is required, because the main use of the SIPO register is to convert the serial data into the parallel data. Next one, parallel in and parallel out shift register. So here the input also given in the parallel manner, and output also taken from the parallel manner. This shift register which allows parallel input. So the data is given separately to each flip-flop and in simultaneous manner, and also produces a parallel output. So this is known as parallel in and parallel out shift register. The logic circuit given below for better understanding. So this is also, here also we are connecting the 4 D flip-flops which are connected, and the clear signals is applied to all the 4 flip-flops. In this type of register there is no interconnections between the individual flip-flops, since no serial shifting of the data is required. So there is no connections between internal, so each and every flip-flops are not connected together. Data is given as input separately for each flip-flop, and in the same way the output is also collected individually from the each flip-flop. So here there is parallel in parallel out shift register. So here we are having 4 D flip-flops. So input is given individually to 4 D flip-flops, and output is also taken individually from 4 D flip-flops. And here also the 4 clock pulses and clear pulses is given to all the D flip-flops, and the input is also given individually, so that is parallelly, and output is also taken parallelly. So this is called as the parallel in parallel out shift register, and this is used as temporary storage devices, and like SISO shift register, it acts as a delay element. So applications, what are the applications of shift register means? So the shift registers are used for temporary data storage, and the shift registers are used for data transfer and data manipulation. The serial in, serial out, and parallel in, parallel out shift registers are used to produce time delay to digital circuits, and the serial in, parallel out shift registers is used to convert serial data into parallel data, as they used in communication lines demultiplexing required. A parallel in, series out shift register is used to convert the parallel data to serial data. So these are all the different types of registers, and mostly D flip-flops are used in all the registers, and based on the input and output, so it has various applications, and it performs various storage applications also. Hope you are understanding this video. Thank you.